This video is part 2 of special products with Surds. So in the last video we had a look at expanding a single Surd, for example, root. So we might have, say, 3 root 5, and then we might multiply it by 7 minus root 2. So in those expansions you multiplied this term outside by all the terms inside. And then we extended this a little bit further to say if you have 3 root 5 plus 1 times 7 minus root 2, and that's where we talked about these are binomial products, and you need to use FOIL where you do firsts, outsides, let's go back, outsides, insides and last. So we're going to be looking at special binomial products in this video, and the first special binomial product we will look at is a difference of two squares, and you need to be able to recognize a difference of two squares. They have a very distinctive look and quite nice to look at. What you've got is the same terms in both brackets, except for they are separated by different signs. So here I've got root 2 in the bracket, in both brackets, and a root 7, but there is a minus joining the root sign, joining the surds in the first bracket, and a plus joining them in the second bracket. Now, if you want to, you can expand these out the long way, but basically you're wasting time, because if you've done a difference of two squares expansion, you would have seen that this turns into a squared minus b squared, and you can find that out just by doing FOIL. And what happens is you get the a squared, but this ab is always cancelled with this minus ab, and that's why you don't end up with a third term, and then you have the minus b squared there as well. So when you're doing this expansion, really the fastest way to do it would be to square the first term, which is my a term, and then minus, it is always a minus, the square of the second term. And we know when you square a surd, these are inverse operations, so they will the square root and the square will undo each other. So we're left with 2 minus 7, which equals minus 5. So when you see a brackets containing the identical terms, but the sign joining them is opposite, so one would be a minus and one would be a plus, then you know that that's a difference of two squares. You really want to be on the lookout and notice when an expansion is a difference of two squares. So here I would square the first term, and then I would square the second term, and there's nothing wrong with setting it out like that, breaking down the mental workload. So 8 squared is 64, and when I square a surd, I can square the 3 first, and I can also square the root 5, giving me 5, and then I can tidy a little bit. So take as many lines as you need. As you can see, I'm taking more than are given, and 64 minus 45, well, that is 19. Now, if you're feeling confident, I'd pause the video and I would give this question here a go and then compare your answer with mine. So pause the video now. Otherwise, if you're feeling a little lost, keep watching with me. So here we're going to do our a squared minus b squared again. So we're going to square the first term. We're going to minus the square of the second term. When I square a surd, we square both the integer in the front and the surd. So we're going to have 4 times 7. And here we're going to have 16 times 2, and that gives me 28 minus 32, which gives me minus 4. Okay. Before you even begin to do this, though, I have to say, if you do not know this expansion, you'll be very confused as to why we're doing what we're doing. So it may be worth the time expanding it out and going, oh yes, I really do only end up with the square of the first term minus the square of the second term. So that's a difference of two squares. The last special expansion we have to look at is a perfect square. And a perfect square will look like two terms in a bracket, all raised to the power of 2. And if you want, you can write this out as a plus b, and then do FOIL. But then you'll be missing out on using that nice little rule that we get, which is when you expand these brackets, you'll have an a squared, and then you'll get an ab here and a ba. Well, that gives you 2 lots of ab. And then finally you'll get b times b, which is b squared. So really what we want to do is square the first term, multiply the terms in the bracket together and double them, and square the last term. So that's what we're going to be doing here. Notice these are not a difference of two squares, okay? We've got one bracket raised to the power of 2, so they have a very distinctive look. So let's do it. Square the first term. It's my a squared that I'm doing over here. That'll give me 2. Then I can multiply these together, that would be minus root 14. Don't forget to take that sign as well. And then I'm going to double minus root 14. That would be 2 root 14. So really that's the tricky bit there. I took the root 2, I multiplied it by minus root 7, so that's minus root 14. And then when you double a surd, doubling a surd is just the same as timesing by 2. So there's an imaginary 1 there. So 2 times minus 1 is minus 2 square root of 14. And then the last bit is quite easy, square the last term. So if I square anything, it's always going to be positive, so I don't even have to worry about the negative in front of the root 7, but I've circled it. Root 7 squared is 7. Then it's just time to collect like terms. I've got 2 and a 7 that I can collect, so I'm going to get 9 minus 2 root 14. And that's a perfect square. Let's try it again. First we're going to square the first term, it's 49. We're going to multiply 7 by 5 root 3. So that gives me, well, 7 5s are 35. So we get 35 root 3. And then I'm going to square the last term. I square the last term, I've got to square the 5 and the root 3. So it's going to be 25 times, well, root 3 squared is 3. So I'm going to start tidying. So I've got 49 plus 35 root 3. And 25 times 3 is 75. And then I'm going to combine the terms that I can. So 49 and 75, what's that going to give? It's going to give me 124, so we're getting 124 plus 35 root 3. All right, one more to go. At this point, if you're confident, I would pause the video and complete this last question without my help and then see if we get the same answer. If you're confused, I would join me and stay with me and we'll do it together. All right, so we square the first surd. Don't forget to square the 6 and square the root 3. So it's going to be 36 times 3. Then we multiply the 2 terms together. 6 2s are 12. Root 3 times root 6 is root 18. And then we square this last surd here. So to square that, I'm going to square the 2 over here, and I'm going to square the root 6. Now it's time to tidy. So 36 times 3, that's like 90 plus 18, so it's going to be 108. And then I've got 12 root 18. Now the root 18 I really should reduce into root 9, root 2. So you want to spot surds that can reduce. And then 4 6s are 24. I'm going to combine my 108 and my 124 to make 132, and I'm going to multiply out those 2 integers over here, the root 9, which is 3, times 12, that gives me 36 root 2. So very heavy on the arithmetic, okay, but worth persisting. You just keep practicing how you're multiplying and squaring these surds. Okay, please watch this video more than once if you need to. Hopefully it helps.